We're talking to Pete Bethune from Earthrace. You wrote a really interesting article, which I read on the internet, about your experiences oil drilling and your experiences with deep-sea drilling.
I was really lucky. When I finished school, and this was back in the 90s, I got a job with a company called Schlumberger, who are the dominant player in what's called wireline, which is the high-tech side of oil exploration. And I was fortunate to work through the North Sea and also through Africa. And I'm privy to how the oil industry works, and I was involved mostly on exploration rigs, a few production wells, but pretty much my job was oil exploration. And I was involved, for example, one rig I worked on, it was right next to where a famous oil rig, the Ocean Odyssey, had sunk a couple of years earlier due to a blowout. And a blowout is the main risk factor that these oil rigs pose. When you drill a well, they hire a rig, the rig drills a hole in the ground, and as they're drilling, they have this drilling fluid. They call it mud, but it's basically a drilling fluid that occupies the hole. When you hit a reservoir, the mud must be of a weight such that it's greater than the pressure inside that formation as you go into it. And almost universally, all wells have a pressure of roughly half a psi per foot. So if you drill a 10,000-foot well, when you get to the formation at 10,000 foot, there'll be about 5,000 psi pressure.
Can we just put that into perspective? Like, is that the same measurement that we use when we pump out the tyres in our car? It's about 30 psi?
Yes, correct.
So that's
so at 10,000 foot, there is 5,000 psi of pressure.
Which is
maybe
huge.
150 times what you put in your bike tyre.
Yeah, that's huge then.
So, but that's downhole. Now, the point I'm getting at, this mud weight, when they get a blowout, what happens is the formation, gas or oil, flows out of the reservoir and pushes out your drilling fluid. And at the start, and I've seen this on a couple of rigs, it's just this sort of gentle flow of mud coming out. But the gas and oil is lighter than your mud, because your mud is at the very minimum is the density of water, but more often than not it could be up to almost double that.
Right.
And so as this stuff starts to come out, it goes faster and faster until you might end up with all of the mud gone from your well, and now you're just free-flowing gas or oil. And that's exactly what happened to the BP Horizon well, where all of the stuff came out. And they have these things called BOPs, or breakout preventers, that sit, depending on the well, on the seabed or sometimes on the actual rig itself. And they are like your last resort. And they have one set called the shear rams, and they are designed to come through and cut through whatever is in the well, be it drill pipe or anything else. It will just cut straight through it. And what happened on the BP Horizon one, there was a series of errors, and ultimately when they pressed the button to close the shear rams, they didn't work effectively, and the well was then uncontrolled. And it took, I think, 87 days for them to bring that well back under control. And the point I'm making on this, and this is my concerns, like I've seen a lot of comment from people who maybe are opposed to the drilling off raglan, but who don't really understand the risk it poses. And what the risk is, if you lose control of a well on land, it's easy to bring in equipment and cap it and sort it out. If you lose control of a well in shallow water, and typically shallow water, they generally mean 1,000 foot or less. If divers can dive up to 1,000 feet,
right?
And if you're putting equipment down like remote operated vehicles and that, it's not so far down. Things don't need to withstand enormous pressures. But once you get over 1,000 feet, it does become much harder to go gaining control of a well that you have lost. And that's what happened to BP Horizon. 87 days it took them, and it just exposed how enormously difficult it is. And if you take your average well, it is unlikely that it is going to have a blowout. I think in the last 37 years, from what evidence I could find, there's been roughly 500 blowouts around the world. So it's not like they're extremely rare. Like you're getting maybe 10 or 15 blowouts per year all over the world.
Right.
And of those, there's been 37 of them that have led to substantial oil damage. So that it does occur, but it's not happening every day. And if we drill a well offshore from Raglan, the odds of us having a massive blowout are not enormous, but the odds are there still, and we may get unlucky. And the problem with these deep sea wells, if you get a problem, it's really hard to regain control of that well.
Yeah.
And that's why, look, I'm not opposed to oil. Like, I don't have a car, but I do travel around a bit. I fly around a bit when I'm on my work, and we use a lot of products that are based on plastics. Or petroleum based, but we can't just ignore. We need to have oil for our entire economy to be sustained. But we do have a choice over where we drill for oil. And when I look at it, the risks on land are acceptable to me. As an oil exploration engineer, they are fine. The risks in shallow water wells, they are definitely greater. But I'm still not opposed to it. But once you get over 1,000 feet, it becomes exponentially more difficult to regain control of a lost well. And that's why I'm opposed to it. I work for an organisation now called Earthrace, and it's taken us a while to come up with our policy on this, but in the end, I'm not going to ever agree to deep water wells while they remain such a high risk thing. And I guess one of the things I learned out of the oil industry is cock-ups are always going to happen, and there's always these unforeseen conditions that you can't always anticipate, like where they're drilling offshore from Raglan, and also they're heading down to Kaikoura in a while. They don't know what's down there. Like, they've run seismic tests to try and figure out what sort of formation, and I believe one of them is what's called a syncline field, where you've got this big sort of arch of shale that traps oil. So there's some interesting looking formations that suggest there may be oil or gas there, but they don't know. And until they drill into that formation, are they going to come across 10,000 psi or 15,000 or 8,000? They just don't know. Every now and then there's an oddball comes along, and our coastline is totally unexplored. Even when you get in highly explored coastlines like the Gulf of Mexico, they've had thousands of wells drilled all through that area, and yet BP Horizon still went down. And that was only a couple of years ago. It's not like it's a historical well. It's only a couple of years ago, and we continue to have these blowouts happening on rigs because you are drilling into difficult conditions. You don't know exactly what's downhole, and there's always a possibility for human error that we just simply can't remove.
Well, Pete, they have been saying that it's 7,000 psi out here as opposed to the 17,000 that was in the Deepwater Horizon. Is that just an estimate, is it?
That's an estimate based on the well depth. So the well that they're drilling, when they're saying 7,000 psi, they probably anticipate that'll be a 14,000 foot well or something like that, most probably. Might be only 12 when they put a factor of safety in, but they don't know. Who's put a tool down there to tell them what the well pressure is? They simply don't know. So they've come up with that value of 7,000 psi, and that is simply based on the well depth. But in all honesty, they have no way of knowing exactly what that mud weight will be, and that's one of the reasons why there was a famous rig in the North Sea called the Piper Alpha that went down, and it lost, I believe it was 127 lives are lost. And that was from exactly that. They thought they knew what the well pressure was. They got down there and they didn't know, and it was much higher than they'd expected.
Well, in your article, you've got a story about you were on a rig, you were called out to a rig that was very close to that happening, wasn't it?
Yeah, that was in the North Sea, and I got called out to the rig as they'd taken what's called a kick, and this is where the drilling fluid starts flying up the drill pipe, and it gets faster and faster unless they close it in. And what they'd done was they'd closed the BOPs and they'd circulated some heavier mud or drilling fluid to try and arrest it. And then they opened up the well, nothing was flowing, and I then dropped down the well an RFT tool which measures the pressure, and so it can measure the pressure inside the well bore, and then it can also poke a probe into the formation, and it would measure the pressure in the formation. And normally you would see a difference of maybe 100 psi, 200 psi, something like that. So your well has pressure much greater than the formation to stop it flowing.
Yep.
And when I set the tool, and I don't remember the numbers exactly, but it was something like 10 or 12,000 psi. And the formation pressure was exactly the same as the hydrostatic, like maybe 0.1 psi difference. Like that well was on a knife edge. And the amazing thing was the mud engineer, he explained to me, he said, look, this is the heaviest mud weight that has ever been used by our company anywhere in the world. And I don't remember the number exactly, but it was something like 1.8. So water has a density of 1.0 grams per cc,
yep,
or say 1,000 tonne in a cube. 1,000 kilos in a cube. This was like 1.8 times like that. And what they do is they add in a product called barite to make the mud heavier. And the mud engineer, he was saying, I don't think we can add any more barite. Like, this is just, this is unheard of, this pressure that we've got down there. And what happened after we found the formation was so overpressured, much higher than they ever anticipated, I pulled the tool out, they closed the well and they pumped heavier fluid still. And then they pulled it, and then they started drilling on, and they ended up, it was quite a decent find. Like, they had over 600 foot of pay, or 600 foot of zone that had oil and gas. But then they had a problem with the drill pipe got stuck. I then ran an operation called a back off, where I set an explosion off above where the pipe is stuck, and they pull that out, and then they go down with what's called a fish, and that they try and sort of jar out the piece of pipe that's left. But they went and did that, and then a piece of that broke off, so now they've got 2 pieces stuck in the well. They then did what's called a deviation, where they drilled down to where this bit of pipe was stuck in the well now, and then they deviate off the side to kind of create a new well down beside it. They went down on that, and then about 2 weeks drilling into that got stuck. I then went in and did a back off to pull that pipe out for them, and then I think at this stage they'd spent $20 million, and it was, BP was the main company, but there was a series of partners in it as well, and they had all decided they'd spent enough money on this well, and in the end they plugged it. So they pulled everything out, and they just plugged it on the surface, on the seabed, with a view maybe to coming back in the future.
Well, actually, that was a question that was coming into my head as you were saying that, like with peak oil and more pressure on resources, what are the odds they go back there?
Oh, pretty good, I would think. It was such a significant find, like 600 foot of pay. There's very few areas in the North Sea that had anything like that. So I don't know for sure. I would imagine it may be in production now. I don't know. But I guess one of the points I should make is that almost all oil wells have the potential for a blowout. It's not as though a super high pressure, the really high pressure ones are more dangerous because you deal at more pressure at the surface. But even if you've only got 1,500 or 1,000 psi at surface, that's still an enormous amount of pressure. And all wells are dangerous. You need to treat them all with respect. And I'm not saying the oil industry doesn't treat them with respect, but just from my experience in the industry, there are always going to be mistakes made, and there will always be potential for disaster. And thankfully on land and in shallow water, those disasters are largely averted because we understand and we're capable to go in and deal with those situations. But these deep water wells are relatively new. It's not like they've been drilling them for 50 years. They're relatively new, and it's such great depths. Like, you try and control a little submarine that's 3 kilometres underneath the rig you're on and go in and do complicated operations on a wellhead. This is really tricky stuff to do. And from New Zealand's perspective, I think we should sit back and let countries like the States and Mexico go and do their deep water drilling, and in 30 years, if it does turn out to be that they have largely gotten on top of the problems, then maybe we should do it then. And maybe we should be leaving a bit of oil around New Zealand for future generations, not sucking it all up now. At the moment, I just see this deep water drilling, it's high risk game. It's environmental roulette, and I don't think we should be party to it.
One of the things they've said is that they've learnt from the Deepwater Horizon event and that they've made improvements, so it's okay now.
Yeah, look, I'm sure they've certainly learnt from the Deepwater Horizon effort. There was that report that went to President Obama, but it basically concluded, and this is even after BP and the majors have all kind of said, look, we need to work better on what happens when we do get a disaster in deep water, and they have come up with some form of capping device that they believe they can lower down on top of a broken well, but it's never been tested. Like theoretically, yeah, hey, they have this one device, but we won't have one of those in New Zealand. You know, this is made for the Gulf of Mexico. So, you know, I think they've spent something like $100 million or something developing this thing, and it's sitting in the Gulf of Mexico. So if we have an enormous blowout here, it is going to take them best part of a month to ship that down to New Zealand, and then it is untested. It hasn't been tested in a real situation. I'll give you an example. The BOPs that they used on the oil rig, the BP Horizon one that was blown up, that theoretically had a 1 in 10 million type of failure. 1 in 10 million. Like it's almost impossible that it would fail, and yet it did fail. And, you know, I've seen enough cock-ups from oil companies when they say, we've got it sorted now and it's safe. They said that after Mexico. Mexico had the third biggest oil spill of all time. I think it was called the Itox or something like that. And it's off the coast of Mexico. And there was a lot of angst in the oil industry about, hey, you know, these massive spills are hurting us badly. And after that, they said they've largely sorted the problems and they've got better technology now. And then BP Horizon happened. Environmental roulette, my friend.
All right, well, Pete, thanks heaps for your time this morning. It's good to hear from someone who's not a PR person and is actually talking some facts and talking from a place of experience. So appreciate your time this morning.
Pleasure, mate. Always good to talk to you.